In this video, we'll start to develop the input control of our character. We will analyze the keyboard input and move our character accordingly. I will start by creating a new folder called scripts, and I'll create a C# script called player controller. I'm gonna open this script, and we are going to start by setting up some variables that we'll need. So first of all, I will need a reference to our camera, and we will understand why shortly. Then I will need a reference to the animation component, so I can, let's call it animation actually, so I can update the animation. So when the character is not moving, he's in the idle animation. When he's walking, he's in the walking animation. When he's running, we use the run animation. And since our character have a rigid body, I need a reference to it as well, because as a good practice in Unity, if your character have a rigid body, you move the rigid body and not the transform in order to keep both the rigid body and transform in step with the physics simulation. I will set up a couple of variables right now. So the camera movement parameters. I'm not sure if I'm gonna use them right now, but I'm gonna keep them set up already. So the first one is called cam smooth time. I'm gonna set it by default to 0.1, and the other one is a smooth velocity, and I'll describe what I'm gonna do to these variables later. Then I'm gonna create some animation control parameters. So this will help me to adjust the animation to the character movement and have a proper velocity to avoid the character from sliding on the floor. First of all, I'm going to keep a flag to check if my character is running, and then I will define a walk speed. Let's set it to 1 by default. And I'm using serialized field on these private variables because I want to keep them private, because best practices, these are only needed in this class, but I want to adjust them in the editor. So serialized field allows me to do that. Crossfade time. So these, let's set it to 0.1. Then I'm going to keep my current animation state. I'm not sure if I'm going to need these, but I just want to keep the name of my current animation. Oh, there's a whole bunch of quotation marks here. And finally, a vector tree direction to flag where my character is moving. Again, you understand in a second why we are doing that. So on start, I'm going to define my references. So first of all, my camera, then my animation component. I'm going to show you, when we get back to Unity, I'm going to show you where this animation component is, and for the rigid body, I'm going to do the same thing, but for a rigid body. And by default, we are not running. Actually, by default, when the game starts, our character is in idle, so I am not running. So on my update, the first thing I'm going to do, and actually I'll have both an update and a fixed update, because again, since we are handling the rigid body will be handled on the fixed update, but I am going to check which animation to use in the update function. So to check which animation to use, I'm going to need two things. First of all, I'm going to need to check if I'm running, and I need to check the input. If I'm moving forward, if I'm moving sideways, if my character is moving at all. So I am going to first create a function called check running, and let's define this function here, check running. And I'm going to use the left shift button. So WASD to move the character around. If you press shift, you run. So I check running. I will check if input get key code dot left shift. There it is. I'm going to set running to true, else running false. Perfect. Let me just double check, because full disclosure, I always confuse get key and get key down. Yes, get key checks if the player is holding the key, and get key down is just the initial down button. So this is exactly what I want. So check running, and then I'm gonna get my horizontal input dot get axis raw, horizontal, and my float v input get axis raw, vertical. Perfect. And I'm gonna set my direction vector3, which is the variable I created up above. This will be a vector3 with horizontal 0 and vertical dot normalized. And why I'm doing normalized? Because normalize caps the maximum magnitude of the vector to 1. Because why we're doing that? Because, so let's say I'm pressing W only to move forward. If I'm pressing W, that means that our vector would be 0, 0, 1. So its magnitude would be 1. However, if I'm running diagonally, meaning if I'm pressing W and D, for instance, that means that my vector is 1, 0, 1, and its magnitude, since it's diagonal, would be bigger than 1. And that means that I would run faster if I'm running diagonally. And normalized prevents this from happening. It's super common in games to see this issue where your speed horizontally and vertically is smaller than if you're running diagonally. So always make sure that for this type of checking, always use normalized. And now that I have the input, so I know if my character is moving at all, I'm going to call a function, let's call it set animation, and I'm going to provide this vector3 that I just created. And let's create this function, private void set animation, and this receives a vector3 called direction. Brilliant. So first of all, I'm going to check, if I am moving at all. So if my direction.magnitude is bigger than 0.1, because if I'm not providing any input, my direction vector is going to have a magnitude of 0, so I'm not going to do anything. And then, so if I'm moving, I now need to also check if I'm running. If running. If I'm running, I'm going to set my current animation state to run, which is the name of the running animation. Else, I'm going to set my current animation state to walk. Okay. And then if I am not moving at all, if my magnitude is less than 0.1, my current animation state equals idle. So that's my idle animation. So if I'm not moving, I use the animation. If I'm moving, I either use the run and the walk. And finally, after this else, I call my animation.crossfade and my current animation state and the crossfade time. So crossfade ensures that the animations transitions smoothly. I'm going to save my script, go back to my Unity project, I'm going to select my player game object, and I'm going to apply this script. So just to show where, so the rigid body we set up on the main game object in the last video, and the animation component is in the rig child game object. You can see the component animation here, and within it we already have the animations that are imported when you import a model from the Anything World browser. So you have the idle, run, walk, and jump animations here. So let's go back to our player game object. We have our script set up. Let's press play and see what happens. So there's our character, our third person camera is working, and if I press W, my character is moving, well, moving quote unquote, but we are setting up the walk animation. If I release the W button, it goes to idle. If I press D, it's also switching to the walking animation. What if I press shift? If I press shift, it starts running. If I stop, it stops walking. Great. So our animation is set up. Let's now move on to setting up the actual movement of the rigid body on our fixed update script. So I'm going to stop running the game. Let's head back to Visual Studio. And on my fixed update, I'm going to do the same thing I'm doing on update. I'm going to get my input. And then I'm going to call a function. Let's call it move character. And again, we're going to pass direction as a variable. Let's do it up here so I can watch it closely. Move character, a vector tree called direction. Great. So on move character, again, I need to check if I'm running or if I'm walking, because depending on the situation, I'm going to use a different speed. So if I'm running, I'm going to call my rigid body reference move position. I'm going to get the current position. Then I'm going to add the direction times run speed. Okay. And if I'm not, already have the else. If I'm not running, I'm going to do rigid body dot move position, the exact same thing, but with walk speed, not run speed. So let's just copy this guy here, remove these, and walk speed. Why did they move character? Oh, private void, move character. Let's save. Let's head back to Unity and let's see what happens now. Maybe this walk speed and this run speed is way too fast. Let's see. I'm gonna press W. Oh, it is indeed way too fast. Let's set it to 0.1 and my run speed to 0.2. Let's see how it goes. See, much better. But as you can see, this is what I was trying to avoid. You see that the walk speed. Well, there's one big problem that as I move my camera, if I press W, naturally, I would like my character to walk towards the direction the camera is facing, and that's not happening right now. I just keep moving forward, and finally I fall. That's problem number one. Problem number two is I gotta move my character a little bit back so we can have a little bit more space to walk. My character is sliding. You see how the foot that is planted on the floor shifts as I move. That's because I'm walking too fast. So let's reduce the walk speed a little bit more to 0.025. Let's see. That looks much better. That is much better in terms of the animation. Let's wait for it to show up. So you see now the feet feels like the feet is planted on the floor. And if I run, but I'm running, I think run is good, right? Let's see again. We need to fix this camera. It's going to make things much easier to see, but yeah, running is okay. It's a little bit, so let's reduce running a little bit. Let's see. Felt a bit shifting on the running. Yeah, now it's much better. Okay, cool. Fantastic. I mean, as you are developing this yourself, you can tinker with the speeds. Let's keep it like that for now. Now, as I said, let's fix the issue that, when my camera is looking this way and I press forward, I want my character to go in that direction, right? So I want to rotate the character to move towards where the camera is facing. To do that, I'm going to go back to Visual Studio. And here on my fixed update, before I call move character, I'm going to create a new function here called private vector tree calculate direction, and this will get the direction too. What's the problem here? Oh, okay. It will return to. So first of all, I'm going to get the angle that my camera is looking at, which would be my target angle for my character. And for that, I'm going to use a little bit of math here. I'm going to get my X and Z directions from my character. I'm going to convert it to degrees, and I'm going to add to that the Y angle of the camera, meaning the rotation of the camera. So this will be my target angle. My target angle is going to be the current angle of my character plus the angle of the camera. And my final angle is going to be, and before that I'm going to do a smooth damp angle. So the movement is not immediate. I have some smoothing, and that's going to be the origin is going to be my current angle, which is my transform Y. The destination is the target angle I just calculated. And I'm going to use my smooth velocity as parameter and the time that I want the damping to take. I have defined this camera smooth time, haven't I? Let's have a check. Yes, I did. Okay, so in 0.1 seconds, my character's rotation is going to go from the current Y to the target angle I have calculated here. And then I will finally set my rotation to the angle I just calculated, 0f, and I'll return this result just multiplied by my vector3.forward. Okay, so now instead of giving my direction to move character, I'm actually going to call calculate direction here with my current direction. So I'm going to call calculate direction, fix the rotation of my character, and after I fix the rotation, I will finally move the character. Let's see how it goes. Back to Unity. I'm going to press play. There's my character moving, and now I'm going to try. Oh, something's not right here. Let's see what is going on. Let's go back to Visual Studio. I'm forgetting to check. I should only do this if direction.magnitude is bigger than 0.1. I should only move my character if I'm actually inputting something. Let's head back to Unity and see if it works now. Walking, stop walking, go to idle, and now, moment of truth. Let's move our camera this way. I'm going to press forward, I'm going to press W now, and there you go. And now my character, if I rotate the camera, my character always moves towards the direction of the camera. And if I press sideways now, I am moving sideways, but keeping relative to where I'm facing. So right now I'm pressing A, so I'm moving left, but I'm always moving left relative to my camera. So that's pretty cool. And that's good that we had that bug, because, you know, it's a teachable moment to all of us. Okay, so now our character is moving. In the next video, we're going to talk about how to set up the jump